Hi class, in lesson 3.8 we will be looking at parts of parts. Learning targets for today, we will be creating models to represent parts of parts, analyzing various methods for multiplying fractions, and then using any of those methods that we are the most comfortable with to multiply fractions. On page 188, problem 1, we will be multiplying with fractions. The 6th grade students are making extra large rectangular pizzas to sell at home basketball games. One extra large pizza costs $24, but customers can buy part of extra large pizzas. Number 1 tells us to create a model to determine the amount of pizza each person bought. Then write your answer below your model. Make sure that your answer is in simplest form, and finally determine how much each person paid. We're going to do letter A together, and then I will have you do letters B through F after that with your group members. If we look at letter A together, Christine bought 1/4 of 1/2 of a pizza. How much pizza did Christine buy, and how much did she pay? So the first thing we can do in order to draw our model is take a look at the second fraction that is listed, and we want to break up the rectangle into that fractional part. So we have the line right here that is breaking up the rectangle into 1/2. Then we want to take a look at that first fraction that we were given, and we want to break up that 1/2 part into fourths. You can see then that 1/4 of the 1/2 is shaded in. So if we think about how much pizza Christine bought, she would have bought 1/8 of the pizza. If we think about the other half of the rectangle, it would also be equal to 4/8. So we have 8 equal sized parts that make up the entire rectangle, and like we said, 1/8 is represented for how much Christine bought. Now we just have to determine how much that she paid. If we look back into the problem situation, we can see that the pizza is going to cost $24, so we have to try and determine what 1/8 of 24 is. If we break that up into equal sized parts, we can see then that she is going to pay $3 for her piece of pizza. So that is how you are going to tackle the rest of number 1. Like I said, I want you to do letters B through F with your group members. For letter B, 3/4 of 1/2, Antoine is going to buy 3/8 of a pizza, and he is going to pay $9. For letter C, 2/3 of 1/4, Paul bought 1/6 of the pizza, and he is going to pay $4. Letter D, 1/3 of 1/2, Katie is going to buy 1/6 of a pizza, and she is going to pay $4. For letter E, 2/3 of 3/4, Sifi is going to buy 1/2 of the pizza and pay $12. And finally, for letter F, 1/2 of 2/3, Gary is going to buy 1/3 of the pizza, and he is going to pay $8. At the top of page 190, the expression 1/2 of 2/3 means to multiply 1/2 and 2/3. Anytime you see two numbers or fractions with the word of between them, remember that you must multiply the numbers or fractions together to get the product. When you multiply a fraction by a fraction, you are calculating a part of a part. You can represent the product of two fractions using an area model. So let's take a look at the example. Let's consider an area model for 1/4 times 1/2 and what it represents. So like we talked about with the previous example, the first thing that I'm going to do is break up my model into 1/2, two equal sized parts, and I have that shaded in with the black. The next thing that I want to do then is break up that half into equal size fourths, and I have that represented with the red. So I have 1/4 that is shaded in, and then the important part to understand right down here is that the overlapping region is going to end up being the product of the fractions. So you can see right here that the black and the red overlap. That is going to be equal to 1/8 then, and that's how we can determine our product using the area model. At the top of page 191, you'll now get some practice in using area models to represent each product. What I would like you to do is letters A, B, and C with your group members. For letter A, the first thing I'm going to do is break it up into 1/2, then I'm going to shade in 1/2. Then I'm going to break it up into fourths and shade in 3 of those fourths. You can see the overlapping regions right in here are going to represent then 3/8 for my answer. For letter B, I'm going to break it up into fourths and shade in 3/4. Then I'm going to break it up into thirds and shade in 2/3. You can see then that the overlapping region is going to be 6/12. We have to make sure that we reduce and we get 1/2 for our answer. Finally, for letter C, I'm going to break it up into thirds and shade in 2/3. Break that up into 1/2 and shade in 1/2. Overlapping region, I'm going to get 2/6, but I have to make sure that I simplify the fraction. 1/3 is my product. At the top of page 192, go back and review the products that you calculated in questions 1 and 2. Now with your group members, I would like you to write a rule to calculate the product of two fractions. For number 3, when you're calculating the product of two fractions, you can multiply the numerators and multiply the denominators. After you are done doing that, if it is necessary, then you must simplify the fraction as well. If we take a look at number 4, then we are going to explore several correct methods for multiplying two fractions. So go ahead and take a look at the 6 students that they have listed, kind of analyze the methods and have a little discussion with your group members, and then we'll discuss them together. Let's look first at Rodney and Joyce. Rodney and Joyce seem to have a similar method where they are just simply finding the GCF. So again, you're multiplying the numerators and the denominators, and you have to check to see if you can simplify the fraction. 12 over 72, you can still simplify that. GCF of those two numbers are 12. You're going to get 1/6 for both of your answers. If we look at Dean's method, he started off doing the same thing, multiplying the numerators and the denominators, but then he came up with factor pairs for 12 over 72 and ended up just canceling out the 12s in order to get 1/6 for his answer as well. Ruby used prime factorization for her method in order to determine 1/6 for her answer. Again, she was able to cancel out the factors that were common in the numerator and in the denominator, was left with 1 for the numerator, and then the 2 times 3 is going to give you 6 for your denominator for 1/6 for your product. Jay did not use the GCF, but he did use common factors that 12 and 72 had. The very first thing that he did was divide by 3, and then he ended up dividing by 4 in order to make sure that he got his fraction of 1/6 in simplest form for his product. Lastly, if we look at Naomi, in my opinion, Naomi's method is the most efficient, but you have to make sure that you are good with your math facts. What she is doing is she is looking at the numerator and denominator that are diagonal of each other, and she is trying to figure out the GCF of those pairs of numbers. So if we look at 3 and 9 first, the GCF of 3 and 9 would be 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. For 4 and 8, the GCF would be 4. 4 divided by 4 is 1. 8 divided by 4 is 2. 1 times 1 is going to be 1 for your numerator, and 2 times 3 is going to be 6 for your denominator. So there is your product in simplest form. So again, 6 methods in order to multiply fractions, whichever method you are the most comfortable with. Of course, all of these methods were correct, so whichever one you are the most comfortable with, go ahead and use that method moving forward. Let's skip over to number 6 on page 194. You are going to estimate each product. Use what you know about benchmark fractions and estimation to explain your reasoning. I would like you to do letters A through D with your group members. For letter A, the estimated product is going to be 2. 3 and 11/12 is close to 4, and half of 4 is 2. For letter B, I have 1.5 times 4 and 1/6. The estimated product is going to be around 6. 4 and 1/6 is close to 4, and 1.5 of 4 is going to be 6. For letter C, 3.5 times 2 and 9/10, the estimated product is going to be 10. 2 and 9/10 is close to 3, and 3 times 3.5 is going to get you close to 10. And finally, for letter D, 2.5 times 5/9, the estimated product is going to be about 1 1/4. 5/9 is close to 1/2, and 2.5 times 1/2 is going to give you about 1 1/4. Problem 2 on page 195, Hawaiian Trail Mix for Everyone. Remember Miss Hadley's Hawaiian Trail Mix extravaganza? It was quite a success, and some teachers are making more batches. Calculate how many cups are needed to make multiple batches. Show your work for each. What I would like you to do with your group members is number 1, A, B, and C. For letter A, we are multiplying 2 1/3 times 3. Our answer is going to be 7 cups of almonds. For letter B, 4 5/8 times 3. They are going to need 13 7/8 cups of popped popcorn. And for letter C, 4.5 times 3, they will need 13.5 cups of raisins. Let's skip over to page 197 and take a look at Leslie's correct method that is shown when we are multiplying two mixed numbers together. So the first thing that she is going to do is turn each mixed number into an improper fraction. She is going to multiply the numerators and the denominators to get her product, and then finally make sure that her product is in simplest form. If we take a look at page 198, this is going to be your homework for tonight. I would like you to do letters A through H for number 3. You're going to calculate each product, show your work, and make sure that you do not leave your answer as an improper fraction. Make sure that you simplify it. We've had a variety of ways, different strategies as far as multiplying fractions, so please use whatever method that you feel the most comfortable with. That's it for lesson 3.8 on parts of parts, multiplying with fractions, multiplying with mixed numbers. Please let me know if you have any questions. Thanks.